In this section, the second section of this unit, we're going to work on just geometric series, or sequence, excuse me. So a geometric sequence is a sequence where each term changes at a constant multiple or rate. In other words, we're going to multiply each time to get to the next term in the sequence. The common rate or ratio is denoted by r, and that's what we're multiplying by each time. So if we take a look at the next section, we want to determine if these are actually geometric sequences. So could you look at the first set of numbers and tell me, are we multiplying by the exact same number each time to get to the next term? In letter A, we are. We're multiplying by -2 each time, so this one would be yes. This is a geometric sequence. In the next one, it looks like we're multiplying by 3, but then by -3, but then by 3, but then by -3, so we're not multiplying by the same number each time. Take a look at letter C. It looks like we're multiplying by 2 each time, so this would definitely be a geometric sequence. And then on the next one, it looks like we're dividing each time, but when you divide, you are multiplying by a fraction, and it's taking half of each number each time, but also it's doing a negative. So 12, half of 12 is 6, but the negative is -6. Half of -6 is -3, but the negative of that is +3. So this one is a geometric sequence. So this is the rule that we will use every single time we are writing a geometric sequence. The a sub 1 is the first term, r is the rate, or what are we multiplying by, and n-1 will be the exponent. So we need to write a rule. So the rule would be the first term, which is 2. The rate, what are we multiplying by each time? So to write the rule, we write a sub n equals the first term times the rate to the n-1 power. So if I want to find the 8th term, I take 2 times 3 to the 8 minus 1 power. The 8 minus 1 power would be 7. So the first thing you have to remember is you must do the power. But if you punch it in your calculator, it will work. You just have to put 2 times 3 to the 7th power, because we want to make sure the 3 is only going to the power. And that will be 4,374. If you're using your phone as a calculator, you're going to need to turn it sideways to use the scientific calculator. So we take a look at the next one following the same rule. Our first term is a 2. We're multiplying by -2 each time. So our rule would be a sub n equals the first term times the rate to the n-1 power. So if I want to find the 10th term, I'm going to take 2 times -2 to the 10 minus 1 power, which will be 9. And if we plug that into your calculator, you're going to take 2 times -2 to the 9th power, which will be -1024. Let's practice another one. So here's our sequence. Our first term is 56. And what's our rate? Well, it looks like we're cutting it in half each time. So our rate is going to be a half. Our rule will be a sub n equals the first term times the rate to the n-1 power. So if I want to find the 7th term, I'm going to put 56 times 1/2 to the 7 minus 1 power. Remember the 7 minus 1, it's easier if we do that right away. And then we can plug that into our calculator. And because we're cutting it in half every single time, we're going to end up with a decimal that's 0.875. All right, let's try a couple of different kinds of problems. So this one says they're going to give us the term, and then they're going to give us the common ratio. So they gave us the fourth term as 3, and then they said the ratio is 3. That means that we're multiplying by 3 each time. So to get the fifth term, 3 times 3 would be 9. To get the sixth term, 9 times 3 would be 27. So if I go backwards, instead of multiplying, I would divide. So 3 divided by 3 is 1. If I want my second term, 1 divided by 3, that's going to be a fraction. And if I want my first term, I'm going to take 1/3 divided by 3, and that's going to be 1/9. So my first term is going to be 1/9. My rate is multiplying by 3. So if I would like to write my sequence, it says write a rule. So that's going to be a sub n is equal to 1/9 times my rate, which is 3, to the n minus 1 power. Now, we also could do this problem in a different way. We could plug the numbers into our formula and figure out what our a sub 1 is. So here's how that would work. I know my answer is 3. I don't know the first term, but I do know my rate is 3, and I know that a sub 4 is 3, so my 4 is my n, so it's going to be to the 4 minus 1 power. So then I can calculate this. 4 minus 1 is 3. 3 to the third power is 27. And then I would divide both sides by 27 so I can find my first term. So you could do that either way, by counting or by calculating, and you'll get exactly the same answer. So now what if I'm given 2 terms and I want to find my rule? This is going to look exactly like what we just did in the last unit. So here's what we did. We took our rule, a sub n equals the first term times the rate to the n minus 1 power. What we're going to do is we are going to plug in what we know into that formula. So if I use this, a sub 2 equals -4, I'm going to plug in -4 as my answer. I don't know my a sub 1. I don't know my rate, but I do know that my n is 2. So I have -4 equals, I don't know my first term, I don't know my rate, but I do know it's to the first power. So we're going to divide both sides by r, and so -4 over r equals a sub 1. Okay, so this should look very similar to what we did before. Now we're going to do the exact same thing with the formula, but use the second set of numbers. Oops. Okay, so we're going to use the second set. We're going to use this set. Okay, so our answer is -1024. I don't know the first term, I don't know the rate, but I know that my n is 6. So this time I'm going to plug in my a sub 1 is -4 over r times r to the 5th power over 1. So what I'll do, if you remember from our last unit, -1024 is equal to, the r's will simplify, so we have -4 r to the 4th power, divide both sides by -4, so we get 256 equals r to the 4th power. To find what our r is, remember we're going to do the opposite, which is we're going to take the fourth root. You can do that on your calculator. So when we do the fourth root, we know that r is equal to 4. So we're going to plug that back in. So negative 4 over 4 equals a to the first. That's going to be negative 1, or a sub 1. And then now we can write the rule. This is one that has a lot more steps. So we have a sub 1, or a sub n, excuse me, equals our first term times our rate to the n minus 1 power. These take a little bit longer to do, a few more steps, so we're going to practice one more. Okay, here's our first set. So we're going to take our answer, first term, rate to the n minus 1 power, but our n is 2. Remember, our n is 2. So now we're going to simplify and divide both sides by r so that we get the a sub 1 by itself. Now we're going to do the second set of numbers. Our answer is negative 405. We don't know the a sub 1, we don't know the r, but we know that our n is 5. That's our exponent. So we're going to substitute in this into our equation, 15 over r, and we're going to multiply that times r to the 4th power, and we'll put it over 1. Like we did in the last unit, we're going to simplify the r's, so it's r to the 3rd power, and we're going to divide both sides by 15. Negative 27 is equal to r cubed. Then we'll take the 3rd root of both sides to simplify, so r is equal to negative 3. We'll plug that back in. 15 over negative 3 equals negative 5, which is our a sub 1. And now we can write our formula, our rule. So a sub n equals our first term, which is negative 5, times our rate, which is negative 3, to the n minus 1 power. This is our introduction to geometric sequences.